Up in the first class, so we're doing this right the second time. You guys are, you get it, you get the benefit of my mistakes. The velocity northeasterly. So if it says northeasterly, you kind of assume that it's exactly northeasterly. That angle right there is 45 degrees, and this angle 90 degrees. And what they want to know is find the actual speed and direction of the aircraft relative to the ground. So when you add vectors, remember, like graphically, the way you add them is by adding the tail of one to the tip of the next one. So if I wanted to add these two vectors together, the result is going to be somewhere over here. But basically, you add the tail of this one, right, to the tail of this one to the tip of this one, and the resultant vector is going to be this one right here, right? So that's what we're trying to find, is this vector, the magnitude of that vector, which will give you the actual speed. So we're going to call this v sub a for the velocity with respect to the air. We're going to call this v sub w for the velocity with respect to the wind. And we're going to call this v sub g for velocity with respect to the ground. Okay, so right, if you're trying to fly this way and the wind's pushing you this way, you're kind of going to end up going that way, right? So using vectors, first thing you want to do is you want to add, this is v sub w as well, right? This is the same as it. So you want to add v sub a plus v sub w, and then you want to find the magnitude of that will give you this vector, and then you want to find the magnitude of that vector, and then you want to find the direction, which is that angle right there. Not that hard, right? So the way you do that is v sub a is just equal to what it's going straight down at 500 miles an hour. So how can I write that as a vector? Hey, you're interrupting my sound quality. Negative 500J. You understand that? And v sub w is going to be equal to, is going to 80, right? So it's 80 cosine 45 in the I direction plus 80 sine of 45 in the J direction. Do you guys understand that? No? And so the V with respect to the ground, I just add those two vectors together. So that's equal to V sub A plus V sub W. And so V sub G is going to be equal to negative 500 plus, I guess I should do the I part first, okay? Sorry. Is going to be equal to 80 cosine 45. I guess we should simplify that. What's 80 cosine 45? That's root of 2 over 2, right? So that's 80 times root of 2 over 2, which is equal to 40 root of 2, okay? And sine of 45 is also equal to root of 2 over 2. So that's going to be 40. That's going to be 40 root of 2 as well, okay? So now what I have, so I'm going to add up my I parts first. So this one doesn't have an I part. So I'm going to have 80 root of 2 over, not over 2. 80 root of, sorry, 40 root of 2 in the I direction, plus the J direction is going to be 40 root of 2, 40 root of 2, plus negative 500 in the J direction. Okay? Now, that's the vector. To find out the magnitude of the vector, remember the magnitude is you take the square root of the square of each of these. So the magnitude of that vector is going to be equal to the square root of, and then you got to plug a whole bunch of stuff into your calculator, 40 root of 2 squared plus 40 root of 2 minus 500 squared. And if you do that on your calculator, you get that b, the magnitude of that is approximately equal to 447, I think. I'm doing this totally without my notes, but I think it comes out. If you know how to plug things into your calculator, right? And if you did that, you get negative 447. Believe me. You do. Negative, or no, you just get 447. You did get negative. 447 miles per hour. So this guy, he's going 447 miles an hour this way. 447, because the wind is kind of slowing him down a little bit and pushing him to the side. Now, in order to find theta, okay, that angle there, you could use a lot of cosines, if you like, but the way they want you to do it is they want you to say that the cosine of theta is equal to v sub a, remember this, v sub a dot v sub g, to find the angle in between two vectors, over the magnitude of v sub a times the magnitude of v sub g. Follow that? Okay, so cosine of theta, that's the formula that we have, right? And so v sub a dot, this is v sub a dot v sub g. So here's v sub a, v sub g, right? So you have to dot this with that. So what's the I component going to be?
0.
It's going to be 0, because this doesn't have an I component, right? So when I dot this I with that I get 0, right? So the I part gives me 0, plus, then all I have to do is multiply this times this, right? Which is kind of messy, but you're going to get negative 500 times 40 root of 2 minus 500, which I think is going to give you a, that's a 500. So that's going to give you a, that's going to be a negative number, right? Times a negative, it's going to give you a positive number. And this part is easy, because we already found v sub a. What's v sub a? What's the magnitude of v sub a? How fast is he's going straight down? V sub a is 500, and we did find v sub g. The magnitude of v sub g is 447. Okay? So if I multiply this together,
Would it be the square root of 500? Oh, no, no.
So it's square root of 500 squared, right? So it comes out to just be 500. So if I do that on my calculator, I get that theta, I get cosine of theta is equal to something. What do you get? Logan?
I didn't get the cosine.
What?
0.992.
0.992, right?
Yeah.
And then what if you take the inverse cosine of 0.992? What do you get? Small angle.
7.24.
Perfect, okay? 7.24 degrees. So that angle there is 7.24 degrees, which you can write, and a lot of you didn't do this on your test, as south. 7.42 degrees, which way? No, that's east, right? Because it's east of south. And so that's how you do one of those airplane problems. All right?
Do we have to write it like that?
Yeah, it says what's the, because that doesn't, if you just say theta is equal to this, I don't know what theta is. Sorry, we're not done yet. Sorry. Last one. Truck on a hill. My truck is stuck. Did you ever, okay, so we're moving on. Let's pause for station identification.
That's a minivan. I used to have one of those.
You did?
Yeah.
Wow. Okay, so we're going to do the truck on the hill problem, and they want you, what they want you to do with this one is kind of write it as a, I think what they wanted you to do was to write this as a decomposition of two vectors, which can be a really pain in the neck, okay? There's a easy way to do it. It's just using right triangle trig, okay? So it says a Toyota Senna with a gross weight of 5,300 pounds is packed on a street in Baston, okay, with a slope of 8 degrees. See the figure. Find the force required to keep the Sienna from rolling down the hill, all right? So basically, what you want to know is how much force do you have to, hold that guy up with, all right? And it's pretty easy, because what you can do is there's also so you could break this vector. There's a weight going straight down, right? And that weight is how much? It says 5,300 pounds. Okay? But also, I can break that 5,300 pounds into one vector that is coming down this way, and one vector that is going, I should have made that a little longer, that is going this way. Okay, good. Oh, I should have gone the other way. If I add this, let me try that again. Okay? Let me go back. Sorry. Back. All right. So I could break that into two vectors. One that's going down this way, perpendicular to the ramp, and one that's going this way at 90 degrees to that. So do you see that if I add this plus this, I would get this, 5,300? So, and that this right here is a 90-degree angle. And you can make little triangles with vectors just like you're making triangles with lengths of stuff, except this stands for forces, right, rather than the length of things. So you're going straight down with 5,300, but then you can do some geometry. Remember geometry? This is a 90-degree angle. This up here, see, remember this thing? Look, remember when they make a Z like this? See the Z? This and this are parallel to each other. You see that? Okay? So if this, they tell you, is 8 degrees, then what does this have to be? Or if that's 90, what does that angle have to be? 82 degrees, which means these alternate interior angles, that one has to be 82 as well. See? So I can break this into two vectors, one going this way, which we'll call, I don't know, what will we call it? Force perpendicular. And we'll call this we'll call it force perpendicular. And we'll call this force, what would I call that? Yeah, we'll just, let's just call it 1 and 2. We'll call this force 1 and force 2. So using right triangle trig, that's all I have to do. I could say that, and I know this is 5,300 over here. Okay, this is kind of confusing. Oh, I'm going to mess things up. I hate when that happens. Anyway, you get that the sine of 82 equals force 1 divided by 5,300, right? And that would give you the perpendicular force. But they want the horizontal force. So the cosine, right, because it's adjacent, this is the hypotenuse of this right triangle right here, right? See the right triangle? Draw it again. This is the hypotenuse. So the cosine of 82 is equal to force 2 divided by 5,300. So force 2 is just 5,300 times the cosine of 82. Can someone do that on their calculator? Cosine 82. Right. Cosine 82 is going to be a pretty small number, I believe, right?
737.
How much?
737.
737.6. So you can, if you can pull, I doubt you could do that by yourself. I would usually try, I would do that, but I would use a rope in my teeth to pull that up the hill. Okay? But That's how much force would be you'd have to apply. Well, it's not the horizontal force, it's the force in the direction of the ramp, right? Go this way, because this plus this has to equal this, so you would have to counteract that with an equivalent force in the opposite direction to pull it up the hill, right? So in the world's toughest man competition, strongest man, I was in that, the world's strongest man competition, but they told me, no, we're not talking about odor, we're talking about your strength, you know, because my brother told me I smelled really bad, so I said, yeah. He said, you smell strong, and then never. Okay. Oh, that was on the video. Okay.